In this video, I am going to solve this homogeneous differential equation. As you probably already know, homogeneous differential equations are defined as follows. dy over dx, if you can represent this as a function of y over x, then it's a homogeneous differential equation. And equivalent definition is this: m of x comma y times dx plus n of x comma y times dy is equal to 0. If that is the case, and functions m and n are homogeneous functions of the same degree, then this is also a homogeneous differential equation. Now let's go ahead and solve our problem, which is dy over dx, and I'm gonna just distribute this denominator. So I'm gonna have, if I were to do this, I'm gonna have y over x, I think, minus 1 over sine inverse, not sine, 1 over sine y over x. This is pretty straightforward and simple. This is something we can solve because the right hand side is actually f of y over x if you look at it. Now all you have to do is do the substitution. Y over x is equal to v, and this substitution will make this differential equation a separable differential equation that we know how to solve. So this is the basic strategy and we are going to follow it along. So that gives me y is equal to v times x, then derivative of y with respect to x. Using the product rule, we get it's to be v times derivative of x with respect to x is 1 plus x times derivative of v with respect to x. And now I can take this value and take this value and plug in here in this equation. So that's going to give me v plus x times derivative of v over derivative of v with respect to x. Now that is going to be equal to, this is just my v minus 1 over sine of v. All right. Now these v and v are going to cancel out. That's going to leave me behind with something very simple. X dv over dx is equal to negative 1 over sine of v. If I simplify it further, it's going to give me negative sine of v dv is equal to dx over x. This is something we can integrate now with respect to the corresponding variables on the left with respect to v and on the right with respect to x. Integral of negative sine of v dv is nothing but cosine of v, right? So that is going to be equal to ln of absolute value of x plus some, let's call some constant ln of absolute value of c. Here I have used ln of absolute value of c instead of just c only to be able to combine these terms. There is no other reason, and you can do it right easily. So that gives me cosine of v. Instead of v, I'm gonna replace my original value back. Cosine of y over x is equal to ln of absolute value of c times x. Okay, because ln of a plus ln of b is ln of a times b. Now if I apply the cosine inverse to both sides, I'm going to get y over x is equal to cosine inverse, let's put it in square bracket just to make it look clear, this. Now my final answer, y of x is equal to x times cosine inverse of ln of absolute value of c times x and close square bracket. This is the solution to this given differential equation. So this is your final solution to the differential equation. I hope that this discussion was helpful. Thank you very much.